Hello, dear students. I am Dr. Shikha Pandey, Associate Professor from Institute of Aeronautical Engineering. I have made the video lectures for the subject that is solid waste management. So, in the lecture series of this subject, solid waste management, today we'll discuss about the type of biogas digesters. Because in the previous lectures, I have discussed you about the anaerobic digestion. So, from anaerobic digestion, we are coming at the point where we are going to discuss about the biogas digester. So first point is that anaerobic digestion is there. We know that inside a biogas digester, some anaerobic digestion can take place. So this anaerobic digestion is just like a degradation of organic material by some microbial organism, and this microbial organism is going to degrade the organic matters that is present in the solid waste in the absence of oxygen. So for this biogas digester, it is like a closed container in which the segregation and feeding of the organic substrate takes place, and in this digester, the biodegradation of substrate takes place under anaerobic conditions and in the presence of some methanogenic bacteria that are going to produce a methane-rich biogas. So this will be the whole picture of this biogas digester. Like what happened? It is a kind of a closed container in which the segregated and the livestock and the organic substrate will be kept inside. So in this digester, the biodegradation of substrate takes place. The biodegradation of the substrate will take place inside this biogas digesters, and it will be placed under anaerobic condition. So anaerobic condition will be there, that I have already discussed with you. And then anaerobic condition will be there. So in the presence of in this anaerobic condition, some bacteria will be originated. So they are called as methanogenic bacteria. So these anaerobic conditions, and in the presence of methanogenic bacteria, they are going to produce a methane-rich biogas. So this generated a biogas, and that can be used for the cooking or electricity generation. So the complete picture about the biogas digester is that the biogas digester can take place inside a closed container, and inside the closed container, all factors are controlled, and all factors are controlled because the control of the factor should be more responsible. So inside the digester, what happened? The segregation and the feeding of the organic substrate take place. The feeding of the organic substrate will take place inside the digester, and the degradation of substrate take place under anaerobic condition. So this degradation will start under the anaerobic condition, means the condition that is absence of oxygen. Absence of oxygen. So this absence of oxygen will cause the methanogenic bacteria to produce among this digester tank, and this methanogenic bacteria is producing a gas. That gas is rich in a methane-rich gas. So this is called as methane-rich biogas. You can see that a digester tank is there. So all organic materials will keep inside the tank. Organic material will keep inside the tank. Then what happen after that? Methanogenic bacteria will start working inside the tank. Methanogenic bacteria, and that bacteria will start working in the absence of oxygen. So in the absence of oxygen, and then what are the outcome? Outcome is the methane-rich biogas. Methane-rich biogas. This is the outcome of this whole biogas digestion process. And this generated biogas can be used for the cooking purpose, or it can be used for the electricity generation. And the fully stabilized digester slurry is there. That slurry is also called as digestate, and that can be used as a fertilizer or soil conditioner depending upon its characteristics. So inside from this digester, we'll get one slurry. That slurry is nothing but the digestate, means the liquid that will be left over after the whole process. Okay, the liquid that will be left over after the whole this biogas digestion process, that is called as slurry. And that slurry is also very much highly nutrients, so that it can be used as a fertilizer into the soil, as a soil conditioner, and depending upon its characteristics, it will be used in different places. Next is like that there are basically three main type of biogas digesters available on the basis of gas storage. So basically three type of digesters are there. So we are talking about the digester, that is the dome shape structure is there. That dome shape structure is called a digester. So this shape will be different depending upon the types of digesters. So first is like fixed dome type digesters, that is called a Chinese type. Floating drum type biogas digesters are there, which is Indian type. And then next is the bag type, that is Taiwanese type. So these digesters can be further divided into two ways based on the procedures. Means when we talk about the shape of the biogas digester, so depending upon the shape, three types are there. First is the fixed dome types, then floating drum type, and then bag type. So fixed dome type is also called a Chinese type. Floating is the mainly called as the Indian type, and the bag type is a Taiwanese type. And the process that takes place inside the digester is like continuous model and the batch model. So continuous models means when the material will be added continuously and the biogas production is uninterrupted. Means continuously the process is going on. Continuously the process is going on. So what happened? Material will be added. The livestock, solid waste, all should be added into the digester chamber, and then biogas production will be uninterrupted. Biogas production will be coming out, and that will be uninterrupted. That is called as continuous mode of biogas production. Next is the batch model. In batch model, what happens? Materials are loaded in one single operation and left until the biogas production ceases. So batch mode will provide it in the batch type, and in the batch what happened? The material is loaded. Material will be loaded into the chamber. Material will be loaded into the chamber. This chamber material will be loaded, and it will be one single operation, and it will be left until when the biogas production will be ceased. Means the biogas production will be completely taken off. Then only it will be leave. So continuous flow is like continuously the material will be added and biogas production will be uninterrupted. And on the second part is like that batch mode. In batch mode, materials is loaded in a one single operation and left until the biogas production will be ceased. So we'll talk about the fixed dome type digester. In fixed dome type digester, it consists of an airtight containers and fermentation chambers that is constructed of brick, stone or concrete. Means some fermentation chamber will be there. So that chamber will be made up of by a brick, stone or concrete. So it will be either made up of by some brick, stone or concrete. So the fermentation chamber is there, and that chamber will be like feed and digested pipes and fixed dome on the top of biogas storage. Fixed dome will be there on the top of the biogas storage. So like this chamber will be there, and on the top of the chamber, see, chamber will be there, and on the top of the chamber one dome shape structure is there. That's why it is called as fixed dome. So next is the storage chamber are connected. Top and biogas is the reaction, and the biogas storage chambers are connected. Sealing is achieved by building up several layers of mortar on the digester's inner surface. So we'll do by sealing of this biogas digesters. Sealing of the biogas digester is achieved by building up several layers of mortars. We'll build up many layers of mortars on the digester's inner surface. And the design of fixed dome type biogas digester originated from the Jiangsu, China. That's why this is also called a Chinese type. Okay, so because the shape is originated from the China, and in the very early in the year that is 1936. In the year 1936, the shape of this biogas digester chambers has been originated, and from the China only. So first, the fixed dome design in India was named as Janta model, and which could not become successful because of the construction problem. So second one is the First fixed dome type of digester chambers has been designed in India, and it was named as a Janta model, and it will be not be successful because of the some construction problem. So some construction problems are there, because of that this fixed dome type digester has not been successful. Okay, so let's see, this is the picture. This came into successor, then again one model came into successor. That model is called as Deen Bandhu model. That will improve the design and consume less building material. So this is a picture of Chinese type fixed dome digester. You can see that here it is the fixed dome type structure is there, and from that structure biogas will be coming out. So this is the digester tank, and this is the inlet. Next is the outlet. So outlet will be slurry will be coming out from this outlet pipe. So typical feed stock for these digesters is animal manure, night soil like human excreta and agriculture waste. So these are the feed stock that can be used in this digester. So in India, that fixed type dome digester has not been much successful, so that the next model has been came into the used. That model is called as Deen Bandhu model, and it will be improved the design, and it will be consuming very less building materials also. So typically food stock for these digesters is like animal manure, night soils and agriculture waste. So they are the most of the feed stock that should be kept inside the digester into this condition for the fixed dome type digester to get the biogas. Now we'll discuss about the next type of digester, that is floating drum type digester. So floating drum type digester is what Jeshubhai J. Patel from India in the year 1956, he has designed the floating drum biogas plant that is called as Gobar gas plant, that will be commonly used in our country. So floating drum plant consists of an underground digester. So in which what happen, underground digester will be there, that is cylindrical or dome shaped, and moving gas holders are there. So gas holder floats either directly on the fermentation slurry or in the water jacket of its own, and the gas is collected in the gas drum, which rises or move down according to the amount of gas stored. In this what happened, this is called as floating drum plant, that will be consist of underground digester, and that digester is in the shape of cylindrical or sometimes dome shaped, and it will be like the moving gas holder. So it is called as moving gas holders, and that gas holder floats directly on the fermentation slurry. That will be floats directly on the fermentation slurry or in water jacket of its own. So this gas holder is basically like it is going to be float either directly on the fermentation slurry or in water jacket of its own, and the gas is collected in the gas drum. The gas drum is there below this structure, and the gas is collected in the gas drum, and it is going to rise or move down according to the amount of the gas that is stored inside this floating drum type digester. So it has been first designed by Jeshubhai J. Patel, and in the year very early, that is in the year 1956, and mostly the shape is like either cylindrical or dome shaped, or a moving gas holder will be there, and then it will be like floats either directly on the fermentation slurry on some horse in a water jacket of its own, and the gas is collected in the gas drum that rises or move down according to the amount of that gas stored. So this type is the most successful type in India, that is floating drum type digesters. So what is the advantage of this Deen Bandhu model? So that Deen Bandhu model is like underground digestion chamber provide good insulation. So the digester chamber will be underground. Everything is underground. See, you can see that this is the picture. So digester will be underground, outlet, gas displacement chamber, all are underground, and improved stability due to lesser variation in temperature underground. So in underground condition, the stability will be more, and it will be improved and more crack proof. Obviously crack is very less inside, because it is all the functions is taking underground And that is like lesser quantity of building material is required, obviously. So lesser quantity of building material is required. So this model, this Dinbandhu model, is very much successful, and it is a fixed dome structure also. So outlet tank, you can see that this is the outlet tank cover, and everything is inside the underground only. All construction is underground only. You can see that this is the digester where gas storage area, initial slurry level is there, and this is the outlet gas, and then displacement chamber will be there. So from displacement chamber, slurry and discharge hole will come, and this is the outer tank. So from outer tank cover, the biogas we can take, and this is the gas outlet pipe also. So here also, and from there also, from here also we'll get the biogas, and then this is the mixing tank, and this is the inlet pipe only. So these are the four advantages. First is the underground digestion chamber that is providing the very good insulation. Next is the improved stability due to the lesser variation in temperatures underground. More crack proof will be there. Then lesser quantity of building materials will be required. So building material which will be required should be in very less quantity, and it will be crack proof only, and improve the stability due to lesser variation in temperature underground. Next type is the bag type or balloon type digester. So bag digester types compromises of a long cylinder of either PVC, that is polyvinyl chloride, or material known as red mud plastic. So a digester that comprises a long cylinder, like a long cylinder type of structure, that structure is made up of by PVC or some red mud plastic. So it has been developed in the year 1974. In the year 1974, this bag type digester has been developed from the residue of bauxite smelted in aluminum production plant. So from the aluminum production plant, this bag type or balloon type digester has been developed, which is very early, not much early, but it is in the year 1974. And that bag is made up of by two materials. First is the polyvinyl chloride, and next is the red mud plastic. The incorporated in the bag are inlet and outlet pipes, and it will be incorporated into the bag, which is of inlet and outlet pipe for the feedstock, and slurry and a gas outlet pipe. So this box has been incorporated in a bag, and that is inlet and outlet pipe will be there for the feedstock or for the solid waste and slurry, and a gas outlet pipe is also there. The feedstock inlet pipe is situated so that the pressure in the bag is kept below 40 centimeter of the water pressure, because if more pressure will be created, then the bag may be burst out. So that the feedstock inlet pipe is there, and that will be incorporated. It will be incorporated in the bag are inlet and outlet pipes of the feedstock and slurry and a gas outlet pipe. So this is like a bag type or balloon type digesters is there, that will be made up by polyvinyl chloride, that is PVC, or red mud plastic. And it was developed in the year 1974 from the residues of bauxite smelted in aluminum production plants. You can see this is the bag type biodigester plant. So this is the picture of a bag type biodigester. So here one inlet will be there, you can see, and this is the gas pipe. So from there we'll get the outlet. Gas pipe will be there, and this is the outlet will be there, and the gas produced is stored in the bag under a flexible membrane. So under the bag, one flexible membrane will be there. So gas which is producing, it will be stored inside the bag under a membrane that is called as flexible membrane. Next point is like that a complete 50 meter cube volume digester will weigh just 270 kg and can be easily installed in the shallow trench. So the complete 1500 meter cube volume digester is like, it will be weight around 270 kg and it could be easily installed in some shallow trench. Next is the feedstock is feed into the bag semi-continuously with the feed displacing an equal amount of slurry removed from the outlet. Feedstock means the organic contents will be feed into the bag. Okay, it will be kept inside the bag and semi-continuously with the feed. Semi-continuously means like continuously with some other feed that is going to displace an equal amount of slurry. So this will be like displacing the equal amount of slurry that will be removed from the outlet. So the equal amount of slurry will be there. That slurry can be removed from the outlet chamber of this biogas digesters. So the bag type biogas digesters is like a feedstock, and it will be like a semi-continuously with the feed displacing an equal amount of slurry removed from the outlet. That's why some pressure should be maintained and this displacement should be maintained inside this bag type biogas plants. So next point is like that the red mud plastic or PVC is unobtainable, means if it will be not available, then the design can also be constructed from the concrete with some flexible gas collecting membrane situated at the top of the container. So you can see this is the picture like the bag type biogas digester. So if this PVC and red mud will be not available, then it can be constructed from some concrete material. Concrete material can be used and it will be like flexible gas collecting membrane. So flexible, this will be like a flexible gas collecting membrane, and that is situated on the top of the container. So its disadvantage is related with it is only that the fabrication material, if it will be damaged, are very difficult to repair, and remote or rural area lack access to repair material and facilities. So if we will make this type of biogas digester into a rural area, then it will be very tough to repair or to remove or to work on this one because of the repair material and facilities. And fabrication material will be there if damaged and it is very difficult to repair it again. Here we are giving to like if this PVC or mud plastic will not be available, then this design can be constructed from a concrete with a flexible gas collecting membrane situated at the top of the container. Next is the type of digesters. Means the digester type means inside the chamber some the process. We are going to discuss about the process. So first one is the single stage digesters and multiple stage digester. In single stage digesters, all the stages of the anaerobic digestion process occurs inside a single tank and compete among themselves. So this will be like inside the tank how this process will take place. So first is like all the stage of the anaerobic digestion will be occur when a single tank and completed among themselves. Next is the multiple stage digester. Multiple will allow the stage of anaerobic digestion to happen in separate tanks. It will allow the stage of anaerobic digestion to happen in the separate tanks. For example, in a two-stage digester, the first two steps can occur in one tank and then the substrate is transferred to a second tank where the methanogenesis occur. Means two tank will be there. Like in first step, it will be appeared in one tank, and then after the substrate is transferred to the second tank where the further process will happen, like the methanogenesis process will occur. So in this way, on the basis of steps of the anaerobic digestion, two stages are there. First is the single stage, next is the multiple stage digesters. Two stage digester is the will involve two step of digesters. From first one, some step will be happen. Then after it will be enters into the second one where the methanogenesis process will occur. So after the methanogenesis process, biogas can be taken from this digester tanks. So the separation of digester as hydrolyzed and methanized change the process dynamic of the digester by allowing the individual bacterial species separately to perform the hydrolysis and methanogenesis. The separation of digester are hydrolyzers and methanizers. Basically two steps are there: hydrolysis and methanogenesis. 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 So methanogenesis are like to change the process dynamic of the digester by allowing the individual bacterial species separately to perform the hydrolysis and methanogenesis. Two-stage reactors will maintain pH for the proper functioning of both hydrolytic acidogenic and methanogenic bacteria at their respective functional pH range. So you can see that this is the biogas. Hydrolysis process will be there inside the tank. So acidogenic stage is there. Next is the biogas is there. So this is the methanogenic stage. So up to hydrolysis stage, it will be happen in somewhere else. Then after it will enters into the methanogenic stage where the next stage will be carried out. So two-stage biogas digester. This is the picture representation of this two-stage biogas digester. And next is the design concentration of a biogas digester. So first of all, we'll discuss about the raw material availability. So the gas production should be proportional to the amount of raw material digested. So gas production is proportional to the amount of raw materials. Okay. Next, we'll discuss about the type of materials. Like what happened, the CN ratio of the raw materials should be in the optimum range for the better digestion. So if the raw material is an easily digestible, the size of digester can be reduced proportionally. So the CN ratio of the raw material should be in the optimum range for the better digestion. Next is the size of raw material. The feed materials should be cut into pieces so that the surface area of the reaction is the maximum, and also it will ensure the homogeneous flow of the waste slurry. So first is the raw material availability, next is the type of materials, and then size of the raw materials. Like all are the basic things that should be considered before designing a biogas digesters. So in case of type of materials, CN ratio of the raw materials should be optimum range for the better digestion. The raw material is an easily digestible one, and the size of digester can be reduced proportionally. Next is the heating requirement and mixing requirement. So for heating requirement, what happened? The digester is situated in a cold area, then the sufficient heating arrangement should be provided to keep the digestion temperature within the optimum range. So what happened? The digester is situated in a cold area, then where will provide the sufficient heating arrangement, like it should be keep in the digestion temperature within the optimum range, and burying the digesters under the ground helps to minimize the temperature fluctuation of the ambient around the digesters. Next is the mixing requirement. Mixing requirement means like it will be providing a mechanism of mixing the feed inside the digesters, and that is going to help to ensure the easy availability of feed to the bacteria for the further reaction. Mixing will ensure proper slurry flow inside the digesters and minimize scum formation. So heating requirement and mixing requirement all are very basic thing that should be considered before designing a biogas digesters. Construction material availability. Use of locally available expertise and material closest to the site for the construction of a digester reduces the cost also. Fabrication from corrosion resistance materials such as wood, ferrocement, concrete, brick or stone rather than a metal may also be reduced cost by extending the equipment life. Larger digesters require proper maintenance also. Removal of inert waste such as sand and rocks prevents wear on mechanical parts and extends the equipment life. So they are the availability of the construction material. Use of locally available expertise and material will be there that will be close to the site for the construction of digesters and reduces the cost also. Fabrication from corrosions like resistance materials such as wood, ferrocement, concrete, bricks or stone rather than some metals, they may also reduces the cost by extending the equipment life. So these are some of the reference of the textbook that you can also follow for the depth study of these topics. Thank you for this lecture. This will be about the anaerobic digestion, and in anaerobic digestion how we can get biogas from the organic waste. So if you have any query or if you have any question regarding this lecture, you can write in the comment box, or you can directly mail me on my given mail ID shikha.pandey@gmail.com. So thank you for today's lecture.
Like, share and subscribe. Hit the bell icon for more updates.